I have 3 ideas for you of geoengineering for Africa. And for the first one, you probably know the Mediterranean Sea and everything that's associated with it. The beautiful beaches, the beautiful towns, the beautiful life that so many people have around it. But what if I told you that actually used to be a desert just 5 million years ago? What would have happened if it had remained a desert to this day? So what happened is the Gibraltar Strait closed down 6 million years ago. And so all the water that was in the Mediterranean could not flow from the Atlantic anymore, and so the sea dried up. Without a sea, you don't have the evaporation from the sea, so you don't have the rain from these clouds. And without this rain in all these areas, you wouldn't have all the civilizations that emerged from there, from the Mesopotamians to the Phoenicians and so on and so forth. And so the world would be a very different place if that Gibraltar Strait had remained that way. We wouldn't have all the civilizations that we know today. Thankfully, around 5 million years ago, one day, the Gibraltar Strait burst and floods of water poured into the Mediterranean. In just 2 weeks, the Western Mediterranean was flooded, and then in 2 years, the entire Mediterranean Sea was recreated. So the question for me becomes, can we not do what nature has done, but as humans somewhere else? Can we replicate the beauty of the Mediterranean Sea somewhere else? And in fact, we already have. If we go here to the other side of the world, to California, this is what happened in the Salton Sea. So the Salton Sea here, which is in California, close to the Imperial Valley, this is one of the most fertile places in the world that creates the most produce. And why? What happened there? Well, the Salton Sea is a depression. It's below sea level. And what happens is the Colorado River here has filled all this area with sediment for millions of years. Here you can see what happened is it fills the sediments, the Salton Sea dried up, and then the river seabed moved, shifted, started filling it again, and then shifts again towards the sea in an oscillation every few million years. In fact, the last time this happened was 400 years ago. That's when the Salton Sea dried up for the last time. So when Europeans arrived around this area, they saw it as a desert. And in the early 1900s, they started building a canal, the All-American Canal, to irrigate it. But they failed, they broke it, and the entire Colorado River was moved towards the Salton Sea, creating the Salton Sea that we know today. They repaired this, but for 2 years, the entire river was flooding into this sea, and then for decades, more water from the Colorado River filled it. And that's how we got this extremely fertile land, but also some of the best tourist areas in California used to be there while the Salton Sea existed. Now it has dried up, but during the time when it existed, it was one of the best places in California for its economy. So can we do more of this? Can we do more of the Mediterranean seas or Salton seas? And we can. We need to look at all the places around the world where there's depressions. And in fact, there's a bunch of them in Africa. Here, I want to zoom into one in Egypt, the Qattara Depression. This is quite big. You can see it here. It's around 100 meters below sea level. It's only 80 kilometers away from the Mediterranean Sea. It's very close from the delta of the Nile and Cairo. So actually, we could, and today is just desert. It's extremely dry, it's salty. Because it's below sea level, it's even drier and hotter than the rest of the Sahara. So there's literally nothing there. So we could simply create a canal or a pipeline to fill it with water. This would create evaporation around it, creating lots of vegetation. And we could do a bunch of things. We could use these to extract some salts. We could, and including lots of lithium that are in this salt. We could have a hydroelectric power plant with the water coming in from the Mediterranean. We could have solar panels, because this is one of the most solar irradiated places on Earth. We can use this electricity to desalinate water, which we can use then to create new cities around it. We can create new tourist areas around it. And then we can even use some of this water to create more agricultural land, which would be good for a country like Egypt, which now today imports food. So there's been studies that have looked at this, and we already even know where we could have the pipelines and what that would look like. Here you can see the Mediterranean to the left, the Qatar Sea to the right. You have a pipeline, then a hydroelectric power plant in the middle. This would also generate a lot of humidity around the area. You can see these areas are green, much greener than around the land around them, because of the water that comes from the seas. This is how we have all these cities that would have been impossible without, and all this population that would have been impossible without these seas. You can see this effect here, for example, in Tehran, the Caspian Sea to the north. You have a coastal rainforest, and then the mountains that catch a lot of the water that then is used for irrigating Tehran. Here you can see the mountains. So we can use the same concept for the Qatar Depression. Not only would it create a lot of potential for cities around it, but also would create evaporation for much more rain around it. And so what could we create? We could literally create any city that we want on a lake, similar to, for example, Las Vegas. Today is dry, it doesn't have a lake, but we could have like a Las Vegas or like a Venice on this dry land, where today there's just literally nothing. Is there a regional precedent? Well, very close by, we have the lowest point on Earth, around the Dead Sea, one of the lowest points on Earth. And today we already have these salt works, this salt extraction in the south of the Dead Sea. We also have some tourist areas around it, tourist resorts. And we could have done much more with it. There were a couple of plans to get water from the seas. One was the Red project, Red Sea to the Dead Sea. That was through Jordan, and so Israel decided not to push for this. They had another plan, Med-Dad, but that went through the West Bank, so they decided not to do this. But instead, what Israel has done for water is desalinate a lot. So today, desalinating water in Israel costs 40 cents per ton. And within 10 years, we can probably get this to 30 cents per ton. This is very, very cheap. Do you know broadly what this means for cost per glass of water? It's less than a hundredth of a cent of a US dollar, or 1 Kenyan cent per glass of water. So it's really literally nothing, right? This is compared to the cost of water around different cities around the world, and you can see that desalinating water this way is cheaper than most of the municipal water in many of the capitals around the world. They get this through these 6 blue points on the coast. These are the desalination plans that they have, and that's how they get 55% of all their fresh water and nearly 100% of all their tap water. They have so much of this desalinated water that they're using some of it to refill the Sea of Galilee at the north when the levels drop too much. And they also use this for exporting water. So Jordan, for example, is a net importer of water from Israel thanks to this. So where can we do this in Africa for less than $1 per ton? You need areas that are dry. You need areas that are close to the coasts and that are not too elevated, because it costs you energy and money to pump water upstream and elevate it. Right? So you can see from these the areas that are the most prone for doing this. In the case of North Africa, you could do this in all these areas of Africa. You could have water for less than $1 per ton in all of these areas. And in the Horn of Africa, you can do this here. This area is low-lying. It's also quite dry. And so you could have in all this area, if you take the overlap of these 2 points, in all this area here, you could actually have water for less than $1 per ton. And with this kind of water, you could literally take deserts and make them full new cities. Can we cool Africa instead? Right? We've talked about desalination, we've talked about creating new seas, but there's another type of idea here where instead we cool the continent so that it's not as hot. Of course, you all know that the world is going warmer, and that's not going to stop because we are generating more and more emissions of CO2 and methane. So this is not going to stop anytime soon. And in a few decades, all of Africa is going to be facing very big risks due to climate change. Flooding, heat stress, water stress, wildfires across the continent. Can we solve this? Can we prevent this from happening? Well, I think we can roll back global warming for $300 million a year. To give you an order of magnitude, this is 75% less than the budget of Real Madrid. So we can do this. How would we do this? Okay. In order for us to cool the Earth, we need to, 1, stop emitting CO2. 2, all the CO2 that we've emitted that has accumulated in the atmosphere, we need to sequester it and get it into the ground. And that's going to take some time. So in the meantime, another option is to reflect some of the sunlight that comes to the Earth. On the first one, on the CO2, can we reduce emissions? Well, a couple of regions around the world are doing so, but the rest of the world is not. And it's important that they don't, because that's what development takes. In a few decades, we're going to have enough solar, enough wind, hopefully enough batteries that we can power all of our economies without emissions, but for the time being, we cannot. So if we want to keep developing, we will have more CO2 emissions. Can we sequester the CO2 that we've emitted? Well, I just checked yesterday, and the current price for CO2 sequestration is $320, which means that if we want to sequester all the CO2 that we've emitted over the last 200 years, it would cost us a few tens of trillions of dollars. To give you orders of magnitude, the current GDP of Africa is a bit below $3 trillion. So these would take tens or like several decades worth of the GDP of all of Africa to sequester all the carbon that we've emitted. So that's not going to happen anytime soon either. So the only option that we have left is reflecting sunlight. If we want to stop the world from heating up, we have to reflect sunlight. And how can we do this? Well, the way the Earth has been doing it naturally for billions of years. This is a volcanic eruption. The Pinatubo in the 1991 had such a big explosion that it ejected some of the dust into the stratosphere, and that cooled the Earth for nearly half a degree for a year or two. We can do the same, right? Thanks to this particle, SO2. This is the particle in the Pinatubo that caused the cooling of the Earth. And out of all the ways to cool off the Earth that scientists have analyzed, mirrors on space in and stratospheric aerosols, like SO2, are the only ways that can cool the Earth enough. And as far as I know, we don't have the technology to put mirrors in space yet. So the only thing we can do is actually doing these stratospheric aerosols. Now, we've been doing this poorly already for more than 100 years. In these fumes here, some of the fumes are SO2. Now, here you can see on red, this is the contribution of gases to climate change, to global warming. And in blue, sulfur dioxide, SO2, that's the one that has been cooling the Earth. So actually, part of the pollution that we've been emitting has been cooling the Earth. Now, the problem with this is that this SO2 is on the lower level of the atmosphere. It's in the troposphere, and that's bad for health because we breathe it. But what we should do instead is take a very small piece of this, just 2% of what we've been emitting, and put it in the higher stratosphere instead. If we do this, two things happen. One, this is 25 times less polluting than when we do it in the lower troposphere, but also it reflects 25 times more sunlight than if we put it in the troposphere. So just 1 gram of SO2 can offset 1 ton of CO2. So just looking at the numbers here, current pollution, we're polluting around between 80 and 100 millions of tons of SO2 every year. Instead of this, we can take this small blue thing at the bottom, and that is what we inject into the higher stratosphere, and that would completely offset all the global warming since the beginning of industrial times. How can we do this? With huge balloons. We put hydrogen and sulfur inside of these balloons, we put them into the stratosphere, and then we burn them there, and that's it. And that's what costs $800 million. If we do this close to the equator, natural flows of the air would distribute these around the Earth and would cool it. And we can already do this today. This is me, actually, in close to San Francisco, in Alameda, 6 months ago, in a small prototype for doing this. So we did this. We released it. This balloon went 20 kilometers up into the stratosphere and released the SO2, cooling the Earth a little bit. How much would it cost? I mentioned $300 million a year, but at scale, this is $800 million. Why? Because you need the cost of the balloons, the sulfur, and the hydrogen. Except that if you're clever, you can get the sulfur and the hydrogen for cheap, actually for free. How? Because these are byproducts of the oil refining process. So we can have sulfur and hydrogen for free through the oil refining process, which is the cause of global warming in the first place. What would be the downsides? So I looked into the papers. I read all the papers about this topic, and they're actually quite small. Here on the downside, these are the lives that would be saved with this, because it would reduce the deaths from ozone pollution. And then above, these are really the only big amounts of deaths that would be added through this. And if you think about it, actually these deaths are the ones that would be happening because we revert global warming. So one thing that people don't know is that global warming is actually in the short term going to save lives because it's going to reduce cold waves. So this is just saying, hey, if we reverse global warming, we're going to prevent these lives saved. All of this to say, this would be amazing for deaths. Actually, there will be fewer humans dying because of this. And then you can look into the detail of all the other costs and benefits, and there's literally no downsides to this. There's a few things that are not ideal, but compare that with the upside of reverting global warming. There is going to be a time in the next few decades or the next few years there's going to be a heat wave so bad that millions are going to die, and somebody is going to say, fuck it, I'm doing this. Because it's only $300 million a year, and you don't need anybody's permission. That's why the president of Kiribati said, it has to be either geoengineering or total destruction. We can do geoengineering to reduce global warming, and we should do it. So these are the 3 ideas that I wanted to have for you today. We can literally make the Earth a better place, and Africa, by creating new seas, by desalinating water to make deserts into lush cities, and by reversing global warming. Thank you.